proton in the Earth's magnetic field moves 2 times 10 to the 6 meters per second east, and the magnetic force is up. When the proton moves north, the magnetic force is 0. If the magnitude of B is 100 microtesla, A, what is the direction of the magnetic field? B, what is the force on the proton moving east? C, including gravity, what is the instantaneous force on the proton moving east? And D, what is the instantaneous acceleration? Okay, so if there is no magnetic force on the proton when it's moving north, it means that the magnetic field is either parallel to north or anti-parallel to north, because in either case, theta, in this case, theta is equal to 0 degrees, and sine of theta is equal to 0, and f sub b is equal to 0. But that's also true for 180 degrees. The sine of 180 also being equal to 0, and f sub b also being equal to 0. So either a parallel or an anti-parallel direction to north would give a 0 force. So now we know in addition, however, that when the proton moves east, the force is up. And so if this is the direction for B, and this is the direction for V, the right-hand rule shows that the force will have the direction up, which is the right direction. On the other hand, if the magnetic field is down and the force is eastward, as shown, the direction of the force using the right-hand rule will be down. I'm using the convention here that an X is down into the paper and a dot is coming up out of the paper. So that means that the magnetic field is due north. B is north. All right, so part B, we're asked to find what that magnetic field is, and the magnetic field is, on the proton, is equal to QVB sine theta, and it's straight up. So I'm going to code that in by having QVB sine theta multiply a unit vector in the z direction, and now we put in the charge of a proton, 1.6 times 10 to the minus 19 coulomb, times the speed of the proton, 2 times 10 to the 6 meters per second, times the magnetic field, 100 microtesla, and then the sine of 90 degrees. This is a 90-degree angle here. Sine of 90 degrees is equal to 1, and so just times z hat, and that works out to be 3.2 times 10 to the minus 17 newtons. Part C now asks what the instantaneous force on the proton is moving east, and if you look at it from the side, here's the proton. There is going to be a downward force, the mass of the proton times g, and as we've just said, there's going to be an upward force, F sub b. And the magnitude of those two forces are, well, F sub b we just calculated, and it's 3.2 times 10 to the minus 17 newtons, and the weight, mp times g for the proton is the mass of the proton, 1.67 times 10 to the minus 27 kilograms, times g. I'll use easy numbers here, 10 meters per second, and that's equal to 1.67 times 10 to the minus 26 newtons. This is entirely negligible compared with that, and so essentially the upward force is just this. Magnetic force is much the greater. The last question is what the instantaneous acceleration is, and we can use Newton number 2 to argue that the instantaneous acceleration is the instantaneous force divided by the mass of the proton. Instantaneous force is 3.2 times 10 to the minus 17 newtons. That's, of course, in the upward direction, divided by the mass of the proton, 1.67 times 10 to the minus 27 kilograms. And that's roughly equal to 2 times 10 to the 10th meters per second per second. Pretty large acceleration because, of course, the mass of the proton is so small.